Okay, so I am going to prove that the focal length is not half of the radius, or the radius of the curvature is not double the focal length. To prove that, we need to know three things. The first one's that if this is a circle, this is its center, this is the tangent, and this is the point of tangency, then the radius drawn from the center to the point of tangency is perpendicular to the tangent. The proof of this is very simple. We know that the shortest distance between two parallel lines is the perpendicular distance between them. So if we draw any other line, then it will be radius. It will be the radius plus some extra length. Similarly, if we draw a shorter line, then also it will be the radius plus some extra length. Only at 90 degrees it will just be the radius. Only at this point of tangency it will just be the radius, so it will be perpendicular to the tangent. The second thing you need to know is some basic trigonometric ratio. If this is a right angle triangle with this angle being theta, this side being the base of the adjacent, this side being the perpendicular or the opposite, and this side being the hypotenuse, then cos theta will be the ratio of base and hypotenuse. Sin theta will be the ratio of perpendicular and hypotenuse. And if we say sin square theta plus cos square theta, for every theta, this will be p square by h square plus b square by h square. Now by Pythagoras theorem we know that p square plus b square will be h square, so this is just h square by h square. So sin square theta plus cos square theta is always 1. So now the third thing which you need to know is the cosine rule. Suppose this is a triangle with this side being A, this side being B, and this angle being theta. Now this is a unique triangle by SAS property. SAS. So let this side be C. We need to find the measure of C in the terms of AB and theta. So first let's draw a height of this triangle. Let this height be h, and let this h divide side A into x and A minus x. So first we will find cos theta. Cos theta is the base or the adjacent over the hypotenuse, which is base, b. So x over b is cos theta, or x is b cos theta. Okay, so now if we apply the Pythagoras theorem on this triangle with sides b, h and x, we will get h square plus x square is equal to b square, or h square is equal to b square minus h square, b square minus x square. So we need this equation and we will need this equation. Okay, so now we will apply Pythagoras theorem on this triangle with sides h, c and a minus x. So h square plus a minus x the whole square will be equal to c square. We need to find c square, so we'll keep it as it is. We'll substitute h square as b square minus x square. So b square minus x square plus, now we'll open this bracket, a square minus x square, a square plus x square minus 2ax will be c square. So now this x square and this x square will get cancelled out. So a square plus b square minus 2a. This x we will substitute it as b cos theta. So 2a x will be b cos theta is equal to c square. So this is the cosine rule. These are the three things we need to know. Here the radius drawn from the center to the point of tangency is perpendicular to the tangent. Then we need to know that cos theta is over hypotenuse, sin theta is perpendicular over hypotenuse, and sin square theta plus cos square theta is always 1. Then the cosine rule which says that a square plus b square minus 2ab cos theta is c square. So now first let's prove that the radius of curvature is not double that of the focal length. This is the concave mirror and this is its principal axis. This is the pole that is page with the center of curvature and this is the focus. Now we will shine a ray at this mirror parallel to the principal axis, so it will pass through the focus upon getting reflected. So now this length is f according to the textbooks. This length is also f. Now if we draw a normal to this ray, it will meet the principal axis at the center of curvature because radius runs from center to the point of tangency is perpendicular. And normal is perpendicular to the tangent for this ray. Okay, so if this angle is theta, according to the laws of reflection, this angle will also be theta, and this ray is parallel to principal axis, so this angle will be theta. Okay, so now look, let this point be A. If we see triangle ACF, it is an isosceles triangle with these two angles being equal. So we can see that this AF length is also the focal length, and AC is the radius of curvature, because it is the point from center to the circumference. Okay, so we know that in a triangle with side lengths ABC, A plus B will always be greater than C, B plus C will always be greater than B, B plus C will always be greater than A, and A plus C will always be greater than B. Okay, so if we look at the triangle ACF, we can see that AF, which is F, plus CF, which is also F, is equal to AC, which is R. So this thing is not possible because of this statement. So we conclude that R is not equal to 2F. Okay, now let's derive a formula for R and F. So let this be the same concave mirror with the same principal axis. Let this be the pole. This is the center of curvature. This is any parallel ray. And this is the focus. This is the normal to the ray. Okay, so now let CF be the focal length. FP is not focal length this time. This time it is R minus F because CP is the radius and CF plus FP is CP. And now ACF is still an isosceles triangle. So AF will also be F and AC is R. So if we apply the law of cosine to the triangle ACF, we will get that R square plus F square minus 2RF cos theta is F square. R square plus F square minus 2F cos theta is F square. Okay, so this F square will get cancelled with this F square, and this minus 2RF cos theta will go on that right hand side. So R square is equal to 2RF cos theta. And now if we'll divide by R on both sides, we'll get that R is equal to 2F cos theta. Okay, now we can see that we know that cos theta lies between 1 and minus 1, but we are going to keep theta only between 0 and 90. If we see, we cannot go beyond 90, we cannot go below 90. So R will always be in the range of R will be greater than 0 and R will be less than 2F. Less than equal to 2F, R will be less than equal to 0. We can conclude this. Okay, now theta, it is very hard to calculate theta. So rather than calculating for theta, we'll assume a length h, the distance between the parallel ray and the principal axis. So for this h will be perpendicular. So this forms a right angle triangle. For this right angle triangle, if we put sine theta will be opposite over the hypotenuse, so h over r. Okay, now if this is h over r, we can say that sine square theta plus cos square theta is equal to 1. And If we substitute the value of sin theta in this, h square by r square is equal to h square by r square plus cos square theta is equal to 1. So cos theta is equal to 1 minus square root of 1 minus h square by r square. Cos theta is r square minus h square by r. So we will need this relation. If we substitute this value of cos theta in this equation, we will get r is equal to 2f square root of r square minus h square by r. If we put everything on the LHS, we will get r square by 2 times the square root of r square minus h square is equal to f. So now we arrived at the conclusion that r square by 2 times the square root of r square minus h square is equal to the focal length. Now if let's just draw the diagram. This is P. Okay. Now if h increases, then the value of square root of r square minus h square. This is focal length here. If h increases, the value of r square minus h square decreases. The value of square root of r square minus h square decreases. If the denominator will decrease, the focal length will increase. So if the focal length will increase, so if h increases, the focal length increases. So if we put the parallel ray far away from the principal axis, then the focus will shift towards the pole. And if we decrease the value of h square, if we decrease the value of h square, the value of square root of r square minus h square will increase, which will decrease the value of f. So if h decreases, then the value of f will also decrease. It's not in direct proportion, but it isn't. If this will decrease, then this will also decrease. So if h will decrease, the distance between the parallel ray and the principal axis will decrease, then the focal length will also decrease, which will shift the focus towards the center of curvature. Okay, now let's look what if h it decreases to 0, it tends to 0. So the limit of h moving to 0 of r square by 2 r square minus h square, which is f. So if h is 0, then the square root of r square will be just r by 2r, r square by 2r is equal to f. This r will cancel, r is equal to 2f. So this formula, which is always in the textbooks, is only true when the distance between the parallel ray and the principal axis is 0.